All right, this is 5.3 using symbols to add fractions. This is the way that I've actually shown in the previous video a little bit. I'm going to write down two fractions here. Let's do 1/4, and let's use some crazy bigger one. Let's do 3/12. Okay. This way I find a lot faster using symbols to do it. I love using it this way because it doesn't involve having to draw all those models that I know some of you are a little frustrated with with 5.1. So here, I've got 1/4 and 3/12. One way we can do this is take our 1/4 and figure out how could we make it into a 12th. We're going to try to find an equivalent fraction. And we can by multiplying by 3. And so the symbol is to draw this thing here, an arrow with a multiplied by 3, and whatever we do to the denominator, we need to do to the numerator, and vice versa. What's 1 times 3? It's 3. So we end up with 3/12. 1/4 and 3/12 are actually equal, which is interesting that those are actually the ones that we're adding. The other thing you could have done is take your 3/12 and see if you can divide it to make it into a quarter, to see if you can turn that 12 into the opposite one. Sometimes you'll run into a problem where it doesn't work, whereas the other way it often does. So we're going to try to make equivalent fraction by dividing by 3. And check it out. 3 divided by 3 is 1. 12 divided by 3 is 4. So we end up with that same thing. So essentially, we could have done either of those. It's either or. We didn't have to do both, and realize that, okay, we have our equivalent fraction. 1/4 we're going to replace with 3/12 and say 3/12 plus, so that's 3/12 plus 3/12 equals 6/12. And finally, 6/12, if we think about it, we can divide that by 6, and also 12 can be divided by 6. Right? We're going to divide by 6. We're going to divide by 6. And that equals 1. And 12 divided by 6 is 2. This is actually equal to 1/2. So 1/4 and 1/4 equals a half. 3/12 and 3/12 equals a half. It's a lot of different things that are equivalent fractions. Here's another example. 4/9 plus 5/6. We can't turn a 9 into a 6 without using decimals as multiplication or division. 6 can't turn to 9 without using the decimals, so we need to do this a different way. We're going to figure out what these equivalent fractions are to each other. And what we're going to do here is use some color coordination with our fractions, denominators. I'm going to take the first fraction, 4/9, and I'm going to try to figure out if I can find a denominator that can be used with another common denominator that I'll find with this 5/6. So we take our first fraction, and we're going to multiply it or divide it. I suggest multiply it by our opposite denominator, which is 6. Okay? We're going to multiply by 6. 9 times 6 is 54. And whatever we did to the bottom, we need to do the top. 4 times 6 is 24. So this is the same number, and it comes from the fraction that is not the one that we wrote down here. Notice this is our pink denominator fraction. And we've come up with this fraction 24/54 is the same thing as 4/9. The next step is to take our other fraction. So right here, we took it and figured it out here. This one, we're going to take and figure it out over here. So 5/6, we are then going to multiply it by the opposite denominator. So here, before we took our first fraction and multiplied it by our second fraction's denominator. Now we're taking our second fraction, and we're going to multiply it by our first fraction's denominator, which is 9. We're going to multiply top and bottom by 9. Color coordinate this. It's the denominator from the first fraction. 6 times 9 has to be the same thing as 9 times 6. It's the same numbers being multiplied. It's still going to be 54. If you get a different number here when you're looking at this, you've done something wrong and you need to check your answers. So 5 times 9 is 45. So we have 24 54ths and 45 54ths. Okay? So we're going to replace these fractions here with their equivalent fractions. We have 24 54ths plus 45 54ths. 24 plus 45. 5 plus 4 is 9. 4 plus 2 is 6. It's 69 54ths. We could take a 54 out of here and make a whole out front, right? 69 subtract 54 would be 15. So we're going to take out one of those 54ths and make it a 1. And we're left with 15 54ths. Now looking at this, I need a little more room, so I'm going to erase this math that I used on the side that some of you could do in your heads. This fraction here, 15 54ths, could we divide that by a number, both those? This could divide by 3, and this could divide by 3. And we find out 15 divided by 3 is 5, and 54 divided by 3 is 18. And we're going to end up with 1 5/18. There are a lot of different ways to do this. Some of you might have realized that we didn't have to go to 54ths. We could have gone straight to 18ths. Some of you might have realized that 9 times 2 is 18 and 6 times 3 is 18. So instead of multiplying by the opposite denominators, what you could have done is multiply by the number that would bring both of these to the common denominator of 18. And you could have skipped some of these steps. I prefer doing this way, just so I don't have to think, oh, what numbers could be working. I just know multiply by the opposite one. I'm going to show that right here, how that works. So I have 4/9 and 5/6. Okay, I realize that I can count up by my numbers. I've got 9, 18, 27, 36. I'm going to count up by my 6's and have 6, 12, 18, 24. Notice we have a common number that we're counting up to, this 18. That could be our common denominator. Okay? So instead of doing it where we multiply by the opposite denominator, we could take our 4/9 and multiply by the number that would make this 18. We could multiply it by 2 and we get 18. Notice it's its second number. It's multiplied by 2 is 18. So 4 times 2 is 8. And we can take our second fraction, our 5/6, to make it 18. 6, it's 1, 2, 3 times. It's the times 3 gives 18. So 5 times 3, our numerator times 3 is 15. So we take these equivalent fractions and replace them in this original statement, expression. 4/9 is actually 8/18. And 5/6 is 15/18. So we're going to take our 8 and our 15. 8 plus 15 is 23/18. Which, if we take our 23 and get rid of 18 of them by making them a whole one number here, use our math, we find out that this is 5 left over, which means this is 1 5/18, which happens to be the same number that we got on the other side when we had this exact same expression right here that we were supposed to figure out how much it is equal to. This way we found our common factor. The other way, where we just use the opposite denominator, skips this step right here where we're figuring out how we can get there. You're free to do either way unless it tells you you have to do it an exact way.